Hello, my dear high school 1 students. How are you? How are your homework? One person sent me a solution. Yes, I know you have few days to find solution and send me your homework via email. But today I have something very similar. So still we are talking about tension. Of course, you can write topic tension examples. Today I'm going to present just one example and give you two problems. The deadline for the problems is next Wednesday. Okay, so here you have 6 days to solve one problem from yesterday and today's two problems. Okay, I hope you remember we were talking about last lesson about tension, tensional force. Your task was to calculate acceleration of the object and tension of the string. Okay, let's imagine a next problem. Let's imagine that you have something like this, a box which lies on the surface. Okay, and this box is connected via a string with another, a string will be blue, with another object which hangs freely here. Okay, masses are known, color, it will be black. Masses of the objects are known. Of course, object 2, this is m1 of mass, let's say 4 kilograms. This is m2 of mass, let's say 2 kilograms. You can use g as 10 meters per second squared. Okay, you don't need to use 9.81. The question is, what is the acceleration of the objects? Of course, this object will be accelerating to the right, this object will be accelerating down, but I'm going to add one more force to the system. Frictional force acting on object 1. Okay, if object 1 moves to the right, yeah, then frictional force acts to the left. We didn't do lesson about friction, but let's imagine that this is a kind of resistive force which acts opposite to the direction of motion. Is it clear? I'm going to use index F, okay, and this frictional force will be given. So let's imagine that frictional force in this particular example is equal to 5 newtons. Okay, so frictional force is 5 newtons, and masses are given. m1 is equal to 4 kilograms, m2 is equal to 2 kilograms. Okay, and your task is to find acceleration of the object. Copy this to your notebook, write topic tension examples, copy this example, stop video for a moment, think for a moment how to solve this, and you will be ready. I will turn it again, and then we will solve together. Okay? So let's look. Let's create forces acting on the objects. Mass m2 experiences two forces, Fg acting on mass m2 and tension of the string. So let's use Ft. Of course, Fg2 is bigger than tension. Sorry, tension T. I said T. Okay, Fg2 is bigger than Ft because mass m2 falls. So overall force is directed down. I'm going to use orange for overall force F2. Is that clear? Okay, so let's write equations for this mass. So M2 situation looks like this. We have Fg2 directed down, tension Ft directed up, and Fg2 is longer, so overall force F2 acts down. What is the main equation? The main equation is F2 is equal Fg2 minus tension. This is our first equation for mass m2. Now let's focus on mass m1. m1 also experiences two forces. Force of tension, which is directed to the right, Ft, and and frictional force, which is directed to the left. Okay? And of course tension is bigger than frictional force because system moves to the right. Of course, it can be a situation when friction is huge that system is at rest because tension is able to keep system at rest, but not in this situation. You will see. Okay, so write equation for mass, and of course tension is bigger than frictional force because all moves to the left, to the right. Sorry. So overall force acting on mass m1 is directed to the right. So in the case of mass m1, we have situation: tension which acts to the right, frictional force which acts to the left. Tension is bigger than frictional force, so overall force acting on mass m1 is directed to the right. Okay, so what is the main equation? F1 is the difference between tension and frictional force. Okay, and based on these two equations, we are able to calculate both end tension of the string and acceleration of the rope. So copy this, stop video for a moment, and try to solve it. Okay, so what is the solution? First, this equation, this one, this. Okay, let's name this equation number 1. Number 1 can be written as F2 is mass 2 times acceleration is equal to Fg2 can be written as m2 times g minus tension. And now this equation number 2 can be written as F1 is m1 times acceleration, Ft is Ft, and frictional force is frictional force. So we have two equations with two unknowns. A is unknown and Ft is unknown. The main task is find A, so I'm going to put numbers and write first equation in the form of Ft. So first equation, Ft is equal to m2 times I said m2 times g, so it is 2 times 10 minus m2 times a, so this is 2 times a, and substitute this to the second equation, which can be written as m1 times a is 4a is equal to tension, except tension I'm going to write this, so it is 20 minus 2a minus frictional force, which is given directly, which is equal to 5. Okay, and now we can solve this second equation. So how many a? 6a to the left, and to the right we have 15, because 20 minus 5 is 15, divided by 6. A is equal 15 over 6, so it's 2.5. Of course, remember about unit of acceleration is meters per second squared, so final answer is acceleration of this system is 2.5 meters per second squared. Okay, please copy this to your notebook. Stop video for a moment, copy this to your notebook, and in a few seconds I'm going to give you 2 more examples, 2 more exercises to solve at home. Okay, ready? So, new slide. Okay, homework number 1, your first problem. We have very similar situation, a flat horizontal surface, and on this surface we have 2 objects, okay, connected by the string. Again, must be better. Okay, so we have 2 objects, box 1 and box 2, connected by the string. Okay, and these 2 objects experience a force F, which will be given. Masses of objects are known. Mass 1 is, let's say, 4 kilograms, mass 2 also 4 kilograms. Okay, there is a friction, so between M1 and M2 the same frictional force acting opposite to the direction of motion. Okay, so friction will be equal to 10 newtons. Force acting on the system is equal to 40 newtons. And your task is to find acceleration of the system. So you have to find acceleration and tension of the string connecting these two objects. So tension here. Is it clear? This is your first homework. And second homework is a little bit different. Let's imagine that you have balloon. This is our balloon O. Okay, let me finish my balloon. Yeah, and a small basket down. Okay, so this is balloon, which is attached to the ground by two cables. Okay, cable 1 and cable 2. Yeah, to the ground, so I have to elongate the ground. And now I have to elongate the cable. Okay, and mass of the balloon is known. Let's say that it's 200 kilograms. A small balloon, 200 kilograms. Okay. You can use g as 10 meters per second squared. Of course, in previous exercise, also 10 meters per second squared. Okay. You know that balloon experiences, except the gravitational force, it experiences a buoyant force, which is given Fb. In this case, buoyant force will be equal to 2,500 of newtons. Okay. And of course, buoyant force is bigger than gravitational force, so balloon tends to accelerate up. It cannot accelerate, it's stationary, so I'm going to write that it's stationary, because it's kept by these two ropes. So each of these two ropes, each of these two cables creates a tension which acts along the cables. And one more data. The angle which cables make with the horizontal is 30 degrees. Okay, so it can be alpha 30 degrees. And your task is to find, remember, balloon is stationary. Okay, so it is at rest, which means that all forces must be balanced. So by using this statement, your task is to find tension of each of the cables keeping balloon at rest. Is it clear? Okay, so deadline for this exercise is in 6 days, so Wednesday at 8 p.m. So practically you have to do this till Tuesday next week. So good luck, have a nice weekend, and see you next week. Bye!